Okay, so we're going to go ahead and begin. So you're all here for the Master of Science in Biomedical Data Analytics program. Pleased to be joined by Professor Dr. Vasilis Marmarellis. He is the Dean's Professor of Biomedical Engineering within the USC Viterbi School of Engineering. And in addition to Dr. Marmarellis, I'm joined by my panelists, William Yang. He is advisor for the Biomedical Engineering Department, along with my colleagues Ray and Camila. So I'm going to just go through a couple of slides, and then Dr. Marmarellis will take it from there. So overview about USC, we're the University of Southern California. We are a private institution located in Los Angeles. We're actually the oldest private institution on the West Coast. We were founded back in 1880. And we are on the semester system. Our student population is around 46,000. What's unique, I feel, for us is we actually have more graduate students studying at USC than undergrads. We have about 24 to 26,000 graduate students at the university. Okay, so it's a very graduate student-friendly population. Within the Viterbi School of Engineering, we actually have a similar ratio as well, that we have more graduate students than undergrads. You see right there. Within the engineering school, we have 8 academic departments, 13 PhD programs, and over 70 master's programs. So at the master's level, you really can specialize in a particular area, such as what you're here to learn more about today, the Master of Science in Biomedical Data Analytics. So without further ado, I'm going to hand off the access to Dr. Marmarellis and make him a presenter so he can speak about this program that you're all joining to learn more about. Thank you so much.
Yes, thank you. I trust you can hear me. Good evening, everybody. I'm glad to be here with you and to try to give you some information about our new master's program in biomedical data analytics. I can see that we have 5 participants and attendees, I should say, not participants. And I will tell you a few introductory remarks, and then I would like to solicit your questions and comments, because that may be more useful to you to direct me with your comments. But let me go down this first slide that I trust you can all see. And it basically states the fact that more and more, the advancement of biomedical science and clinical practice relies on the sophisticated analysis of large amounts of data. And such large amounts of data are becoming available more and more so because we, of course, advance and improve the means by which we collect data, we acquire data. Therefore, the direction of the future is clearly the direction where we will have to analyze large amounts of data that will become increasingly available, and do so in a way that we can advance both the science and the practice of medicine. And in that I include, of course, biological sciences and the related practice of, let's say, pharmaceuticals, etc. Of course, it is obvious that such sophisticated analysis, I call it, just simply to set apart from kind of pretty basic standard type of data analysis that you can be exposed in many different programs or courses. To name an example would be regression analysis, for instance. Regression analysis is extremely valuable. It has, paid tremendous dividends. I do not put it down. I simply want to say that it's pretty run-of-the-mill, and therefore it's not what I would call sophisticated data analysis at this point in time. Nonetheless, we can make good use of it in connection with our more sophisticated methods as well. So the type of methodology we use to achieve this kind of sophisticated so-called analysis are developed, of course, in research centers in universities, and also, of course, research centers could be both industrial and government research centers. And those, after they are developed as methodologies, which is really the primary task of us as engineers, They are subsequently tested, validated, and deployed in clinical sites. And in that process, of course, we have to be participating, and in a very critical role, actually. But certainly we need the primary involvement of clinicians and other professionals who give us access to the particular domain of medicine that we're interested in. The key takeaway is that we believe that in our biomedical engineering department, we are at the forefront of such methodological development. And if you enroll in our master's program, we will be able to share with you some of this so-called advanced methodologies we developed, along with some of the methodologies that have been developed in other places. I should note that the photo that I have in this slide is not my photo, and I'm not quite sure how it found itself there, but that's quite all right. I don't mind. It looks like a rather complicated piece of machinery there, but we don't do complicated pieces of machinery. We just do software, of course, as you can imagine, and mathematics and computational sciences. Going on to the next slide, I would like to point out that the program is unique in its emphasis and really long track record on such methodological development, and especially in the case of time series data analysis. I would like to take a few minutes to explain to you what is the distinction between other types of data and the time series data and analysis, as well as their utilization for what is called here the dynamic modeling of biomedical processes or systems. In the types of data that one can collect, of course, there are many different types, but in a very broad sense, one could separate them in data that are categorical. In other words, you collect data of whatever you're interested in, and you just make columns of such data in a spreadsheet, let's say, or equivalent. Could be also data that you collect in sequence over time by monitoring a specific variable of interest over time, using, of course, the appropriate instrument. This series of data that we collect over time, we call time series data. The analysis of such data reveals the dynamics of the underlying process that we are observing. And this leads us to the concept of what I have underlined in this bullet that says dynamic modeling of biomedical process/systems. Again, what this means is that by doing such analysis of time series data, we are able to discover the kind of mathematical or computational relationships that underlie the generation of such data and pertain, of course, to the system of interest, and do so in a dynamic sense, revealing the dynamics of those processes. To use a very simple example to illustrate this, consider that you have the ability through could be a simple wearable actually, to measure the heart rate of a person and also the blood oxygen saturation level. So you have two variables in this simple example I'm using, heart rate and blood oxygenation. Of course, they both vary all the time in each one of us. By performing the type of time series and data analysis that I'm referring to, what you can do is you can extract dynamic models of the dynamic relation between blood oxygenation and heart rate. That we call that model, dynamic model, is really a mathematical or computational relationship between those two variables. And that is extracted from the specific data you collect through, let's say, wearable or equivalent. Of course, this can take place in the hospital as well, or a clinic. And that model now has its value in revealing to you the relationship between those two variables, tells you something about what's going on in your own body with regard to the relationship between those two variables. In this particular case, the first thing that comes to mind as an example is the function of the so-called chemoreflex regulation. So, a basic physiological reflex we all have in our bodies, and the study of that is of extreme importance in my view, quite underrated, I have to say, and one of the most common, actually one of the most recent reminders of how important this is what you may have read in the media about some severe COVID-19 cases over the last few months that exhibited very severe hypoxemia, in other words, a severe drop in the oxygen level in the blood of those unfortunate patients without necessarily triggering the normal reflexes that one would expect if the chemoreflex of those individuals was properly functioning. And the proper reflex will be an increase in heart rate, an increase in respiratory rate, and a few other effects. So I'm just offering this as a quick and simple example of what one can learn. I would like to stress that the importance of such piece of information and knowledge is both scientific and clinical. Scientific because it advances our understanding of the systems, therefore builds a foundation for the future of medicine, and clinical because, of course, it can be used potentially to assist the physicians in the clinical setting and, of course, save lives or improve lives. In the short time we have, I think that's one example that I think illustrates the point that I'm trying to make with regard to dynamic modeling. I'm taking your time and mind to do so because that's not so widely understood or appreciated. Perhaps I'm wrong, and I would like to have, of course, your feedback on that or questions in a few minutes if you want to share with us. What I just described was the founding principle, actually, of our biomedical engineering department 45 years ago. And the guiding principle for a series of NIH-funded research centers, one of which I led with Professor D'Argenio for 35 years, a long time. And those have been dedicated to this academic mission. And it's a point, obviously, of pride, but more so and more importantly for you, it is a piece of evidence that, in fact, we know what we're talking about when we talk about this particular topic. In terms of career opportunities, I believe there's exciting employment prospects, obviously in health-related research institutions. This can be in academic universities, or it could be industrial. It could be also government-related, like NIH. It is also, there are possibilities in what I call data-centric industries, which are many these days and continuously growing in number and strength, as well as government agencies. This could be, CDC, or guess one could put even NIH under that. Also, hospitals and healthcare data management analysis can utilize these skills more and more. And last but not least, health data-related technology startups, which I think have a very bright future. And one of my sons is clearly interested in that, for instance, and I'm pleased that he does so. In addition, of course, you could use this as a springboard to continue on to PhD studies in a related subject. Now, see, a lot more can be said, but I will kind of limit my remarks to give you a chance to ask me questions. I think that the quote we have on the left is I like it. I resonate with it. The data analytics will be a key factor in the development of new medicine in the 21st century. and we would like to be at the forefront of such innovation. Now, this sounds grandiose and perhaps a little overreaching. I have no problem accepting that. However, the essence of the statement is really valid and intact. If we are to transition into a new medicine this century, we will have to rely on a much more sophisticated analysis of data that we may also, of course, acquire as well. It's not just, first we have to acquire them, then we analyze them. But both are needed. One cannot be without the other. And it is my strong belief, and hopefully you will share that same belief, that the path to the new medicine that we all hope to have in your lifetime, being much younger, and I may not see it in my lifetime, but I hope in your lifetime and my son's lifetime, you will see this, what I call new medicine, which will benefit from this sophisticated data analysis and do a much better job. Yes, I would like to say a much better job than we do now in terms of healthcare. I will close the remarks by showing you the curriculum. I imagine you had a chance to look at the curriculum. I don't want to go down the list of courses, but I could respond to questions if you have such. The titles are kind of self-explanatory. These are our faces, myself and my two colleagues who are contributing to this joint effort. And these are several of other colleagues who also participate in teaching these classes. I would like to hear from you if you feel like it, to tell me what brings you this evening to this, whether you're interested and if you have any questions. But clearly we are looking for people who have active minds, like I'm sure you all do have, and driven, the problem solvers, and we're attracted to big thinking. And also you must have a fairly strong academic record and clearly a strong and sincere interest in the field of biomedical engineering and data science. Yes, in prior courses are not necessary. So I guess that completes the remarks. And unless the host wants to say something on this.
No, thank you so much, Dr. Marmarellis. I would like to encourage our attendees, if you do have a question for Dr. Marmarellis, please go ahead and ask in the Q&A box on your screen. So I'd appreciate if you did that. And we did a quick survey prior, Professor, just to gauge some of the panelists' background or the participants' background. And we had a BME major, bioengineering major, electrical engineering, and signal processing major. People with those backgrounds, I would imagine, would be okay for a program like this, correct?
Yes, absolutely. Correct.
Wonderful. Okay. So yeah, please do start if you have any questions. I do want to mention that this upcoming cycle, fall 2021 applicants, the GRE is actually being waived due to, we try to be equitable in terms of, people's access to the GREs with COVID and the pandemic. It may be difficult for some and not others. So we have decided to waive the GRE for fall 2021 applicants.
I will need your help if there are actually questions, because I cannot monitor them on I don't see where I should be looking, if there are any. Please let me know if there are.
Okay. Yeah, I think we're just right now waiting if anyone has a question. If not, that's fine too. Let me see here. Is there, someone has asked a question about research. Is there a research component to this program? Perhaps, this person claimed, difference between a master's and PhD in a similar field. Are there research opportunities for this program?
Yeah, that's a very good question, actually. And my brief answer is that, yes, there are opportunities that are not part at this point of the formal curriculum that we recommend. The reason is simply space in them, and I'm referring to units in the recommended curriculum. We do try to cover quite a bit of material, and we could not put formally directed research as a possibility of a certain number of units. However, I think our department and school has a tradition in being flexible to anything that's rational, makes sense. Therefore, if one has specific research interest, then it can work out with the proper person in the program an arrangement where this person can take directed research for a certain number of units instead of a certain class. So that can be accommodated if such interest exists. But normally, this is a rather course-intensive program.
Excellent. Thank you. Thank you for that. Let's see. I have another question. Let me see. What are the differences? I'm not sure we'll be able to answer it. What are the differences between this program and the concentration of biomedical engineering and electrical engineering? We actually don't have a concentration of biomedical within our electrical engineering department, so I'm not sure about that one. Someone's asking if there is research dedicated to brain-computer interface. I'm not sure within biomedical data analytics if there is. I'd imagine not, but I will ask you if you know.
The question was about BCI, brain-computer interface.
Correct, yes.
It's an area that we have had quite a bit of presence in terms of research over the years, primarily through the work of my colleague Ted Berger and his associates and myself in my lab. Other people as well have done work in our department, of course, but I'm most familiar with the research I just mentioned. So we have done quite a bit on that, but at this point, that area of research is active, but not in a big way, the way I see it, at least from my vantage point. There are people in the School of Engineering who are interested in BCI and do have active research programs. But I will have to defer to them for more specifics. I would not. What this program may offer to the BCI is simply some methodologies to analyze the data collected through those brain and computer interfaces.
Great. Had a question from an attendee. How does this program approach or take advantage of time series data coming from common wearables like Fitbit or the Oura Ring?
Mm-hmm. Yeah, very much. The brief answer is very much so. I'm trying to choose my words so that I don't take too long. You know, professors like to talk a lot, so I'll be careful with this since it's late in the evening for all of us.
This is great.
But definitely, my answer is definitely strongly affirmative. In other words, we can. I would like to see as I already indicated, one of my sons has such an interest, and I certainly encourage it, and I follow with great interest. Obviously, I myself have an interest in that, but it's competing with others. But again, the answer is absolutely yes, and I would like to see more young, ambitious, driven, highly intelligent people like you be involved with that. Yes, absolutely. Wonderful. I gave an example also of that. It was a simple example by necessity, but you can imagine there's a lot more one can do with blood pressure. I'm talking about things that you can easily measure these days, aside of heart rate and oxygenation. And I would like to think that as we become more sophisticated, we'll develop also sensors that will give us access to more wearable data.
Thank you so much. Does anyone have any additional questions for Dr. Marmorelis? Okay. Well, if there are no more questions, I just want to remind everyone about our application deadline. The deadline's listed on the slide here. We do have an earlier application deadline of December 15th for scholarship consideration, and we do have a limited number of merit-based awards that are partial scholarships. If you apply by the December 15th deadline, submit your online application and transcripts. They just need to be original transcripts scanned and uploaded into the application portal. Then you'll be considered, if you're admitted, you'll be considered for these scholarships. There's an interview process as well in regards to that. Our final application deadline is January 15th of next year, so just know the two distinctions between that. I did have another question come in while I was talking about the application deadlines, asking what computer languages or software does the program focus on?
We mostly use actually MATLAB because it has become quite a standard in our particular field of system modeling, data analysis, signal processing, etc. But I really don't want to rule out other possibilities that one can use other types of popular computer languages these days to write these programs. I would leave that open, but in terms of instruction and part of the courses, I would expect that MATLAB will be the software language that will be used primarily.
Thank you.
But I should note that you understand my limitations in speaking on behalf of my colleagues who teach their courses, because I do not tell them what to teach exactly. We agree to teach specific particular topics and a general outline, but of course there is possibility for the specifics are up to each instructor, as you understand. So this answer of mine primarily concerns the courses that I will be teaching, which is two of the courses using the curriculum.
Yes, and it looks like, just going over that briefly, there are 5 required courses and then 2 electives, I believe, 8 units that the student can select from. So there's a little bit of flexibility for a student to choose and select.
Right.
Mm-hmm.
Right.
Okay.
Design like that, right. Correct.
Okay. Okay. Well, thank you. Yeah.
Thanks, everybody.
Thank you so much for your time, Doctor. I will let you go. If you have any further questions, if our attendees have any further questions, please don't hesitate to reach out to us. My name is William, by the way. I forgot to introduce myself in the beginning. And I work for the Viterbi School of Engineering on the graduate program side. So please don't hesitate to reach out to any of us. And we look forward to hopefully seeing your application and potentially meeting you next fall.
Very good. Have a good evening, William, and the rest of you.